Hi and welcome to this on Maths prediction for the Edexcel Paper 3 Higher Tier Maths GCSE. Enjoy! Hi and welcome to this prediction from On Maths for the very last paper. So this is going to be filmed before any of the papers, so please bear that in mind when you watch this. The papers are very condensed, and so it's very difficult to set new videos out. But this paper is still based on all the previous exam paper questions that have come before, including the June and November ones in previous years. And we look at what comes up loads and what is long overdue coming up. Don't also forget you can do this online by clicking here, and it's completely for free, and you can sign up for free and save your scores so you can track your progress with this. On our site it's also the topic busters, which are very focused on specific topics, and there's all the Maths GCSE topics there, so you can practice a specific topic rather than the more generalised. You can also do the revisionator, which will just blast you with random questions. It normally takes about 10 to 15 minutes to complete. So if you've got less time or you want to do something regularly every night, then that's a really good idea. Don't also forget that the online version is random numbers. So the methods and questions will be the same as this video, but the answers will be different, allowing you to do multiple times. If you like this video, please click like. And if you want to see more from us, please click subscribe. Also, just bear in mind that this is a revision tool. Please do all of your normal revision as well. I hope you enjoy this video. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation, where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue. When you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, factorise means put it into brackets. So looking at the first one, there's a t I can divide out of both of them, so I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. You can check your answer by expanding the bracket. It makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorise fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w? Well, 3w. And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's 2 things that we're dividing out this time. So I'm going to have 8a on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times a by to get to a squared? Well, that's going to be a. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16a? So it's just going to leave it because the a is on the outside of the bracket. So a to a times 2 is 16a, so I don't need an a there. First thing we need to realise with this question is, which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then, what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2, I need to go 2 left, so 2 left, and let's have a think, how much up do we have to go? So 1 jump, 2, 3, 4, so 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. These questions are just based on a few rules of indices. The first rule says that if you've got two powers with the same base, which these two do because they're both a, you add the powers. Now if you think about it, a squared is a times a to the power of 6 is a times a times a times a times a times a. So in total we're timesing a by itself 8 times. So it's 8a to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay. First thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. A term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so the next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of -7. Okay, now we're left with the s's, and it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of -7 s to the power of 7. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5 and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be +6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question because it says grams, which is mass, per centimeters cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that, but we haven't got the volume. So the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-sectional area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So it's the area of the triangle. We've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9, times 10. Now, the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles. And don't forget to halve it. Now, what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimeters cubed, because every unit is in centimeters, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5, and I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise I could do 5 times 180, well I can do 10 times 180, which is 1800, then halve it, which is going to be 900, and then half times 180, which is 90. So that's 990. So the answer is 990 grams. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59, so 59 would be right up here. 25, 35, 15, a little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines. So no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council are saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got 2 decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out 1 and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got 2 exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them, because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Okay, so for the first thing to do with this question is to write it out twice. Whenever you square something, you times it by itself, and itself is the bracket x minus 15. And there are multiple ways of doing the next bit. I'm going to use the grid method for this one. And we put the first bracket at the top, so x minus 15, and the other bracket down the side, which is just x minus 15 as well. And we're timesing, so x times x is x squared, x times minus 15 is minus 15x, x times minus 15 is minus 15x, and then minus 15 times minus 15 is plus 225. Okay, then these two here will add together. So when we write our answer, it's x squared minus 30x plus 225. Now the really common answer to this is people thinking it's x squared plus 225. Okay, and that is wrong. Okay, students do that, and I'll put a big cross through it. Students do that because they don't understand that you're squaring the whole bracket, you're not just squaring the things inside the bracket. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X, and I realise that it needs to be trigonometry because this is a rectangle, that's a right angle, so I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse, so we're going to use sine, so SOH, so it's going to be sine 68 equals 27 over x, and I'm going to times both sides by x and divide both sides by sine 68, so that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68, and that gives me 29.1204. And I just do a few more decimal places than usual because it's not an answer and you should never round your working out. If it's asking for 1 decimal place, I think 4 decimal places should be enough. But I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90 because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22. So that's 22 degrees. Now I'm looking for this one, so CE. I'm going to call CE Y. And I've got, so what have I got? I've got the adjacent here, so this is now the adjacent, and I've got the hypotenuse because this is opposite the right angle. So this time I'm going to be using cos, so it's CAH, so cos 22 equals equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah, and it says it wants the answer to 1 decimal place, so it's going to be 31.4. Now if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine, you'll get the same answer. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do, so either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always, and 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So in your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89, and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89, and press equals. You might get a fraction, just press S to D, and we get 1030 pounds 34. So I've rounded that to nearest penny, because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to £917. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorise it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorise it. Because when you factorise it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16. over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2, and we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner. I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is on the Casio calculators you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it, and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2, and you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2, so what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done, so we can cross that off. Okay, next one, we want to do the line x equals minus 1. Okay, so where does x equal minus 1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals minus 1. Okay, so where do we not want? Well, x is going to be greater than minus 1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, now the last one, I'm going to do the line y equals x plus 2. Now, there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. And 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R. Okay, so this question doesn't have any amounts in it. What you could do is put an amount in it. So we could pretend that there's 100 people in the town, and then see how long it takes for us to be beneath 43 people. That's absolutely fine method. I'm going to be doing this with multipliers though. So it says it's decreasing by 8.1%. So let's work that out as a multiplier. So we always start off with 100%. We're taking away 8.1% because it's decreasing. So we can do that on the calculator or in our head. Hopefully the answer is 91.9%. And then we need that as a multiplier. So 91.9%. Divide it by 100 to get it as a multiplier, and we get 0.919. Okay, so this is our multiplier. Whenever we times something by this number, we're decreasing it by 8.1%. Now, what we're going to do is we're going to use our calculator to work out how long it takes for that to go beneath 43%. So we're going to start off by typing in 0.919 on the calculator, but then pressing equals, and that stores it in the calculator, and that would be 1 year. We're going to times it by 0.919 again, which would give us the second year, and press equals. And because we've done it that way, if I then press equals again, it will give me the third year. Now at the moment it's 0.84, so it's nowhere near that. So I'm going to press equals again. That's the third year. 0.77, so not there yet. Press it again. 0.71. Again. 0.65. Again. 0.6. So we're getting close. Again. 0.55. Again. 0.50. Again. 46. So we're getting very close. And one more time, hopefully. And 0.429. Okay. So it's taken 10 years. Now to show that, show the examiner that, I might do 0.919 to the power of 9 to show it's not enough, and then 0.919 to the power of 10. So 0.919 to the power of 9, that wasn't enough. 0.467, blah blah blah. 0.919 to the power of 10, and I show that that is enough. 296, blah blah blah. So it's going to take 10 years. The easiest way I've found to work with bounds is just draw a number line, put the number that you've got, so we're looking at x, put the number you've got in the middle, try and figure out what the next number down would be. So the next number down would be 1.1 if then rounded to the nearest one decimal place. What's the next number up? Well, it would be 1.3. So the next thing to ask yourself is, where's the cutoff point? What stopped it from being
1.1. Why did it round to 1.2? So the lowest it could be is halfway between those two numbers, which is 1.15. So that is our lowest bound, lower bound. The upper bound, the higher bound, would be here, which would be 1.25, but we're not asked for that. So 1.15 is the cutoff point. Now this is a slightly harder question in B because we're given this formula here. Now we've got to be careful when we're using formulas. We're looking for the upper bound of t, so we're looking for t to be as big as possible. Well, for t to be as big as possible, x needs to be as big as possible because we're adding it and we want a number to be big that we're adding. But the bigger y is, the smaller that fraction becomes. So we want actually y to be as small as possible. If you ever think about it, the fraction a half and the fraction a third, which is bigger? Well, a half is bigger. So the smaller the number at the bottom, the bigger the fraction. Anyway, a little bit of a side note, but that's really important that you remember that if there's a denominator, that we want it as big as possible to make as small as possible number, or as small as possible in this situation to make the number as big as possible. So we need to find the upper bound for x and the lower bound for y. So using the diagram I drew earlier, 1.25 is the upper bound. Now you might say to yourself, well hang on, no, technically 1.25 would round to 1.3. Okay, let's delve into that a little bit. The actual answer should be 1.249 recurring, but there's two reasons I've not written that. The first reason is that it's a pain to work with. Typing that into the calculator would be a pain. The second thing is that actually 1.249 recurring is the same as 1.25. They are exactly the same number. Now if you don't believe me, a little bit of a side note, a third is 0.3 recurring. 2/3 is 0.6 recurring. Following the same pattern, 3/3 would be 0.9 recurring. But we know 3/3 is the same as 1. So 0.9 recurring is the same as 1. There is no difference, and that's very difficult to get your head around. Anyway, side note over. So the upper bound of x is 1.25. So we need to do a little number line to get the lower bound of y. So it's 4.6, so the next one down would be 4.5. So the cutoff point is going to be halfway, which is going to be 4.55. So that's going to be our lower bound, 4.55. So to find the upper bound of t, we need to do 1.25 plus 1 over 4.55. So let's just do that on the calculator. 1.25 plus fraction button 1 over 4.55, and I get the answer 1.46978 blah blah blah. It says it wants it to two decimal places, so it's going to be 1.47 because that 9 would round that 6 up. This question could be a show that question where it gives you the decimal and the fraction, or it could just ask you to work it out. So it could turn up on either paper. So the first thing I'm going to do is just convert this. I'm just going to be investigating this first, and then I'll worry about the 0.0 later on. Okay, so way of doing this is get x equal to 0.8686 blah 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 recurring. Now we need to bring that 86 in front of the decimal point, so I'm going to times it by 100. So I'm going to work out 100x is 86.8686 blah blah blah. And then what you do is you just take away going downwards. The reason we do that you will see in a second. So 99x, because it's 100x take away x, which is 99x, and it's 86 point recurring pattern take away 0 point recurring pattern. The recurring patterns take away, so we're just left with 86. I'm then going to divide both sides by 99. So it's x equals 86 over 99. Now, I said I'd ignore the 0.0 bit. I'd ignore this bit earlier. Well, I can't ignore it anymore. So how do I get from 0.86 recurring to 0.086 recurring? Well, I'm just going to divide by 10. So what I want to do is I want to do 86 over 99 divided by 10. Now the way I can do that is just times the bottom of the fraction by 10, and that's the same as dividing it by 10. And we should write 0.086 recurring equals, to show the examiner that that's what we're doing. Okay, so we can cancel at this point. If you have a look, we can divide top and bottom by 2. So we're left with, I can show that I'm dividing by 2. So we're keeping the fraction the same. So that would be 43 over, and half of 900 is 450, half of 90 is 45, so it'd be 450 plus 45. And you don't need to show this working out, but I'm doing it just to show you. So it'd be 495. Now, I don't think there's another number that goes into 43 and 495, so I'm going to sort of leave it there. Normally when you're asked to simplify, or normally when the numbers are big, you won't be asked to simplify it, or there will be a very easy way of simplifying it. So with this, it's an algebraic fraction, but just think of it as a normal fraction first. So just think you're doing a half plus a third. How would you do it? Well, you've got to get the bottoms the same. You've got to find a common denominator. Now the way we do these when they are algebraic expressions is just multiply both of the algebraic expressions together. So with a half plus a third, the common denominator would be 6, right? So you get that by just timesing the 2 and the 3 together. Now that doesn't always get you the best common denominator to use, but it will always work. It's just sometimes the numbers get a little bit big. So we're going to do that. Now whenever you see an expression in a fraction, always just imagine or physically draw in brackets around them, and that helps us. Now the common denominator between both of those is going to be just those two brackets. So what I want to do is times both of the left hand side by the right hand bracket, and times the right hand side, or yeah, you know what I mean, times the right hand side by the left hand bracket. Okay, so when I do that, I've got 3 times x plus 2 at the top, and then I've got x plus 5, x plus 2, plus 9 times x plus 5 over x. Now I'm going to write x plus 5 first, just so it looks the same. Okay, now we can just add the tops now. So I can just add the tops together, and the bottom is the same, so I'll just write it once. Now I'm going to expand the brackets at the top, so 3x plus 6 plus 9x plus 45. Okay, now I need to collect the like terms at the top, and I'm just going to put this into my answer box. Now it might need it expanded, so I'm going to expand the bottom as well. So the bottom will be x squared plus 7x plus 10. If you don't know how to do that, see our video on expanding quadratics, or expanding quadratic equations, or expanding quadratic brackets. And let's collect the like terms at the top. So 3x plus 9x is 12x, and then 6 plus 45 is 51, and that's my final answer. Now in the exam it doesn't always need you to expand. I could have left the bottom with brackets around it, unless it explicitly tells you to. So I think on the website for this question it asks you to expand all the brackets. So if the question asks you to, you do have to. Okay, there's quite a few different ways of doing this question. I'm going to do this with a tree diagram, but you don't need to use a tree diagram for this question. I just find it a lot easier. So we're going to first of all understand that when you take two tiles, you can't take two tiles. You take one and then another one. Okay, so you move away from this idea of being able to take two. You can't. You take one and then you take another one. So the first pick can either be an 8, a 10, or an 11. So it's an 8, a 10, or an 11. And then the next pick, well, if you pick an 8, you can pick another 8, a 10, or an 11. If you pick a 10, you can only ever pick an 8 or an 11, because there's only one 10. And then 11, you can pick any of the 3 again. Okay, so with 8, you can pick another 8, 10, 11. With a 10, you can pick an 8 and 11, and that's 8, 10, and 11. Okay, now the most important thing we realise is let's work out which outcomes will end up with the second tile. Okay, and we should probably label this. This is the first tile, and this is the second tile. So which outcomes end up with her having a larger second tile? Well, this outcome here, 8 and then 10, 8 and then 11 will. If you pick a 10, then you can pick an 11, and that's larger. And if you pick an 11, you can't get a larger second tile. So there's 3 outcomes you can get with this, with the second tile being larger: 8 and 10, 8 and 11, and 10 and 11. Okay, next we need to work out the probabilities. Well, all of the first probabilities are going to be 1 out of 7, because there's 7 tiles. Okay, so the chance of picking 8 is 2 out of 7, because obviously there's 2 8s. 1 out of 7 for 10, and then 4 out of 7 for 11. Okay, next, if you picked an 8, then there's only 6 left, and there's 1 10. So that's going to be 1 over 6. And I'm only going to be working out the fractions of the ones I'm interested in. So 8 and then 11. So if you picked an 8, there's still 4 11s left, but there's only 6 tiles. And finally, if you pick a 10, then there are 4 11s still, and there's 6 in total. Now, we work out the probabilities by multiplying the lines we went down. So let's have a look and see what lines we're going down for the first one. So we're going 2 over 7, and then 1 over 6. So it's going to be 2 over 7 times 1 over 6, times the tops times the bottoms. Okay, next line, we're going to do same line down here, but this time we go down here. So it's going to be 2 over 7, but this times 1 over 4 over 6. So that's going to be 8 over 42. And the final line, we go down the 10, and then we go down the 11. So it's going to be 1 over 7 times 4 over 6, which is going to be 4 over 42. Now, whenever we've got multiple outcomes, and it can either be this one, or this one, or this one, we add them together. Okay, so the probability is 2 over 42 plus 8 over 42 plus 4 over 42. So 2 plus 8 is 10, plus 4 is 14, so it'd be 14 over 42. And if you cancel that down, 14 over 42, you can half top and bottom, half top and bottom, and then I think you can divide them by 7, so you get 1/3. So the answer is 1/3 chance. Okay, so this is a question on iteration, and we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus Well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer and use a 2 here. Now, you might think that's a lot of effort just when I could have pressed a 2, but you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a third or something on your calculator, just press S to D. So that gives me 3.585 blah blah blah. Now, the beauty of these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088 blah blah blah. Now, you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208 blah blah blah. So it says it wants the solution correct to 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21.
Okay, to answer this question, you need to understand the sine wave. And the sine wave starts at 0 and then goes up to 1 at 90, goes back to 0 at 180, down to -1 at 270, and then back up to 0 at 360. Now, what's happening here is we're taking away 30 before we put it into sine. So at this point here, sine thinks we're at 0, because that point there is 30. So we're going to do 30 take away 30, which is 0. Sine thinks we're at 0, which it will spit out the 0 as the answer. Similarly, at this point here, it's 120. We're going to take away 30, which is 90, so sine thinks we're at 90. So all the way along here, sine thinks that we're kind of 30 to the left. And so it will be very similar to a sine wave, but it will just have moved to the right. I'm rubbish at drawing these. That was really poor because that went up too quickly there. And this is kind of a stretched out one. So we're going to go up to here, then we're going to go back down to here. Now notice that it doesn't start at 0, it starts somewhere, and I've estimated here, somewhere there, and it doesn't end at 0, because it will go back to 0 at 390, because then we'll do 390 take away 30, which is 360, so it doesn't end at 0. So the rule is that if you minus something within a function, then it moves right by that amount. And it's counterintuitive. You'd think if you take away 30, it will move left 30, but it goes the other way, and hopefully I've explained why. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimetres at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry.
Now the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that, so that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angled triangle here, we have two of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimeters and 5 centimeters, and all of them in centimeters, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras, so we're going to square them, add them, and then square root it, and we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61, and we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Oops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11, and we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it X, equals opposite over adjacent. Tan X equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that X is 54.62438 blah blah blah. It says it wants its 2 decimal places, so the answer I'm going to write is 54.62. Okay, so we've got a cubic graph here because it goes down then up and then down again, and we're asked to find the equation of the graph. Now the problem with this is the normal method is to put down 3 brackets, and any solution it gives us in the graph we write down the opposite, the inverse sign, right? So for this one here it would be x minus 6, because 6 take away 6 is 0, therefore that's a solution. And for this one here it would be plus 7, because 7 take away 7 is a solution, right? Because it equals 0. But the problem we have here is we've kind of run out of solutions, and therefore the natural thing is to think, well, maybe it's a quadratic. But we can see it's not a quadratic, it is a cubic, so it needs to have 3 brackets. And not all cubics make 3 brackets, but this question will. So we've got to think, well, hang on, we actually have 2 solutions here. We've got the down solution and we've got the up solution. So that actually represents 2 solutions, not 1. And if you have a look at here, we've just got 1 solution because it just goes through once. So when it turns on the axis, it gives us 2 solutions. So there are 2 lots of x plus 7. So a bit of a unique situation that, but it's useful to remember. The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency density and class width were at the bottom and frequency at the top. Now, it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these, because I'll need to know what they are. So the first class width, we're at 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10, and the last one's 15. So when I've got the class widths, I can work out the frequency density. Now the frequency density is the frequency according to the triangle divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well, that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator, it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2, so can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, so that would be perfect. So I can go up in ones on the 5 squares, so it would be 0.2 here, because they're 2 squares, 0.4, 0.6, 0.8, 1.0 or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high and it's 0 to 10, so we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20 and it's 0.1, so it'd be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one because it's only one square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up one and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40 and we want it to go across here. So we're looking for an estimate for the amount that are in here. Well, if you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6, because the total frequency for that bar is 6 and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4.
I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.